Exercise 1.1. First question, is 0 a rational number? Can we write it in the form P by Q, where P and Q are integers and Q not equal to 0? So the question is 0 a rational number? Can you write it in the form P by Q? I have already told you 0 can be written as 0 by 1 is equal to 0, isn't it? So it can be represented as 0 by 1, that is P by Q form. The rational number is a number which can be expressed in P by Q form, where Q should not be equal to 0. Here the 0 is in the numerator, so 0 can be represented as 0 by 1, which is a rational number. So 0 can be represented as a rational number. The next question is, find 6 rational numbers between 3 and 4. So you have to find 6 rational numbers between 3 and 4. So the numbers are 3 and 4. 3, 4, first converting it into rational number. 3 is 3 by 1 and 4 can be rewritten as 4 by 1. Then taking a number which is greater than 6. As usual I am taking 10. You can take any number which is greater than 6. Then multiplying both numerator and denominator with 10. Now you get 30 by 10 and 40 by 10. So you have to write the numbers which come in between this 30 by 10 and 40 by 10. That is 31 by 10, 32 by 10, etc. up to 39 by 10. So this is the answer. If you take 20, you get a 60 by 10 and 80 by 10. Then you can write the numbers in between them. You can take any numbers. Just make sure that it is greater than the numbers you have to find out in between them. Next, find 5 rational numbers between 3 by 5 and 4 by 5. So 5 rational numbers. You have to find 5 rational numbers between 3 by 5 and 4 by 5. Here 2 rational numbers are given, so you don't have to convert it into rational numbers. But it is 3 by 5 and 4 by 5. We don't know any other rational numbers in between 3 by 5 and 4 by 5. So we are taking a number and multiplying it in the numerator and denominator in order to find the numbers in between them. Here, as since the denominator is same but numerator is 3, then 4, then we don't know any other rational numbers between this 3 by 5 and 4 by 5, and that is why we are changing it into another rational number. This with the same value. That is like that we are multiplying the numerator and the denominator with a value which is greater than 5. As usual I take 10. Then it is 30 by 50 and 40 by 50. Then we get 31 by 50, 32 by 50 up to 39 by 50. This is the answer. You can take 100, then you get a 300 by 500 and 400 by 500. Then 301 by 500, 302 by 500. That's the answer. So any number you can select, but it should be greater than the number of rational numbers you have to find out. The next question is to check whether these 3 statements are correct or not. First one is, every natural number is a whole number. Every natural number is a whole number. Natural numbers, we know it is 1, 2, 3, and the whole number is 0, 1, 2, 3. Every natural number, 1 is there in the whole number, 2 is there in the whole number, 3 is there in the whole number. So every natural number is a whole number. But every whole number is not a natural number because 0 is not there. So the answer is yes. That is, every natural number is a whole number. Next is, every integer is a whole number. Every integer. Integers represented by Z consists of negative numbers, 0 and positive numbers. And the whole numbers consist of 0 and positive number. So there is no negative number in whole numbers. So this statement is not correct. Every integer is not a whole number because integers consist of negative numbers which is there not in the set of whole numbers. Third is every rational number is a whole number. Every rational number. Rational number is something which we can represent in P by Q form. Every P by Q form or every number which can be represented in P by Q form is a whole number. Whole number consists of 0 and positive numbers. If we have 6 by 7, it is not there in the whole number. Then 5 by 9, not in the whole number because it consists of only 0 and natural numbers. That is 1, 2, 3. There is no this type of numbers there in the whole numbers. So every rational number is a whole number is a wrong statement.